Welcome to qnawire.
Alright guys, we're doing problem 104 in chapter 8 of Chemistry of Central Science. So barium azide is 62.0% barium and 37.9% nitrogen. Azide has a net charge of -1. Determine the chemical formula of azide. Azide. So we're going to do this. So 62.04 times times 62.04 grams. We're assuming we're dealing with 100 grams substance times 1 mole or 37.3 grams equals 0.518 moles barium. And for azide, 37.96 grams. As we can look up the molecular weight of nitrogen. It's going to be 14.01 grams per mole. That's going to equal 2.710 moles of nitrogen. So then we divide this, so 2.710 over 0.4158. That's approximately going to be equal to 6. So we have our formula B, A, and 6. Now, barium has a +2 charge and azide has -1. So we're going to have 2 azide molecules. So that means that every azide molecule is going to be N3. So that's going to be azide, N3 minus. So what are 3 resonance structures for the azide molecule? Yes. So azide can come from this. This. So this is going to be +1 and -2. It can be like this. So this is -2, this is +1, and it can also be like this. So this is -1, +1, and -2. So -1. Now for part C, which structure is going to be the most important? So the one that's going to be the most important is one that minimizes the charge, or rather you can say it spreads out. So it's going to be this one, because the other one are going to have, you can't have too much of a charge on one specific atom. So if this one is going to be the most important, then both are bond length lengths should be double bond. And so let's look that up. So typically for nitrogen bond lengths, for NN it's going to be 1.45 angstroms for N, and double bond is going to be 1.25, and for N, triple bond is going to be 1.1. So each of these should be 1.25. So this one, that's going to be 1.25 angstroms, and this one should also be about 1.25 angstroms. So that's theoretically what we should have. For our two bonds, but it also as bonds. In this case, we would have about 1.25. Sorry, this is 1.45 angstroms, and this would be 1.1 angstroms, approximately. So it looks. So it most likely would be the overall structure would most likely be something like this. So you're gonna have partial triple bond character and partial partial double bond character. So it's most likely going to be, but we can split the difference. This is going to be maybe around 1.3 angstroms, and here it's going to be close to about 1.2 angstroms. Wait, sorry, not 1.3 angstroms. This should be close to about 1.2 angstroms, and this one should be close to about, yeah, I would say maybe 1.3 angstroms.